All right, welcome back to the second lesson of this unit, combinatorics. We're going to be looking at permutations of different objects today. Okay, I'll explain to you what permutation means. But before we do that, let's look at this one question here. This should be uh, rather simple. You can see that we are trying to evaluate this without a calculator. Hopefully you can, you know what to do here. You can simply reduce those and then cross them out and you get 6 times 5, which is 30. Okay, this, we're going to use this technique, I guess, this lesson. So that's why I show you this first. What I'm going to show you right now is what we call the factorial notation. Okay, so factorial, what this is actually related to what we just did. Okay, so factorial is like this: n factorial. Okay, this is called n factorial. It's an exclamation mark. Okay, not n, it's n factorial. Okay, so n factorial is equal to n times n minus 1 times n minus 2 times all the way to times 3 times 2 times 1. Okay, this is what we call factorial. For example, if you need some numbers to to understand better, 5 factorial means 5 times 4 times 3 times 2 times 1. Okay, so that's what factorial means. Okay, so you simply just multiplying by the number that's one less than its previous. Okay, so let's look at these three examples here. We want to oh, by the way, there is a factorial symbol on your calculator. So I believe that that's what it looks like. Actually, I think this is what it looks like. So look for that button. We're gonna use those. Okay. However, because n factorial, the numbers actually gets quite big quite quickly. I think this one you'll be able to do it, but you won't be able to evaluate 100 factorial in your calculator simply because the number is way too big for the calculator to handle. Okay, so what we need to do is we need to think about what it means. Okay, so again, 43 factorial simply means 43 times 42, 41 times 40, 39, 38, and so on. So 40 factorial, and then we are dividing by 40 factorial. So then same thing, we can simply cross out the 40 factorials. And this, if you put this into calculator, just 43 times 42 times 41, you should get 74,046. Okay, so I'll let you try the second one and I'll show you the last one. Okay, so hopefully you got this one here, 100 factorial. You don't need to actually expand that. The one you need to expand is the one in the denominator. So this is going to be 101 times 100, 99, 98, and so on. So simply 100 factorial. So then you can reduce those. So your answer is 1 over 101. Okay, now we could have some expressions without just numbers, right? We can have variables. Same thing. What you want to do is you want to expand the bigger term. Okay, so what I mean by that is, you see that's a bigger number, right? So we expand that one. 43 is the bigger number, so we expand that one. If you look at these two, the one that's bigger is n factorial, right? Because then that becomes n times n minus 1, because we want one less than its previous number, so n minus 1. And then m minus 2 factorial divided by m minus 2 factorial. Again, they will simply cancel out. So you end up with n times n minus 1. If you want to expand this, you get n squared minus n. Okay, so this is what factorial is. We're going to use factorial notation in permutation. Okay, so now I'm going to tell you what permutation is. It says here, arranging a set of objects where the order matters. Okay, this is important. Okay, order is important. Okay, order matters is called a permutation. So we arrange. So last time we were looking at arranging letters, like all of them, right? If I believe the example was like the word English, and we were or we arrange all the word English using all of its 7 letters. Now, we don't always have to use 7 letters, right? We could use only 3, only 2, only 5. So there's a way to do this using permutation. Okay, so now again, the key for permutation is that order is important. Okay, order matters. What we're going to be looking at a few lessons down the road is we will also look at something that's that the order does not matter. Okay, we'll look at that later. So what does it mean by order matters? Well, order matters Okay, I'll show you an example, right? Order matters means AB and BA are not the same. Okay, AB and BA are not the same because order is important, right? So AB and BA is not the same thing. So if order does not matter, then in that case, AB and BA, they're the same thing. Okay, so order matters is permutation. Order does not matter is something else. Okay, and what that means is AB cannot equal to BA. That is permutation. Okay, order is important. So I'll show you some examples of examples of what order matters means. Okay, what it looks like. Okay, so here's the example. How many different ways can you rearrange the letters in the word Kelowna? Okay, so this is where the order is important. Okay, because this is definitely not the same as K, L, E, O, W, and A, right? They are not the same thing. So order is important because how you pronounce it, it's different, right? So in this case, we've seen it last time. We have 7 letters here, so it's going to be 1, 2, 3, 4, 5, 6, 7. You have 7 choices, 6 choices, 5, 4, 3, 2, 1, and so on. Notice how this is simply, if we simplify this, simply 7 factorial, right? So again, you can use the 7 factorial button or the factorial button on your calculator to figure out this answer. This is going to be 5040. Okay, so 7 factorial. Okay, so here's the practice. Easy, maple, 5 letters. Hopefully this isn't too difficult for you. You should know how to do this one by now. It's just going to be 5 factorial. If you put this into a calculator, you should get 120. Okay, 120. So again, this is when we are selecting all or using all the letters. We do not always use all the letters. Okay, so here it says if we are only going to arrange some of the objects, then we can use the formula NPR. And this is n factorial divided by n minus r factorial. So again, you can find this button on your calculator as well. But I think for now, we're going to use the formula to actually evaluate. Just to practice. You can definitely use the calculator button on in the future. Okay, for sure. Okay, so NPR, what does N stand for and what does R stand for? Well, here it says N is the number of objects in total. What? N is the number of objects total. What? N is the total number of the objects, and R is the number of objects that we are choosing. Okay, so N is the total, and R is how many we want. Okay, notice how N is always bigger than R. Okay, or I guess bigger than equal to R. You could select all of them, right? So not a problem. N is always greater than or equal to R. So here's the example. How many ways can you arrange 4 of the letters in the word Kelowna? So again, there are 7 letters in total. We can just pick 4 of them, right? NPR. So 7P4. 7 letters, and I'm picking 4 of them. By definition, this is going to be n factorial, so 7 factorial, divided by 7 minus 4 factorial, n minus r factorial. This is going to be 7 factorial divided by 3 factorial, which then is going to be 7 times 6, 4, 5, and then 4, and then 3 factorial divided by 3 factorial. Again, you can see that you can cancel them out. If you put this into a calculator, let's see, you should get 840. 840. All right, so you can see definitely less than using all 7 letters for sure. I mean, we're only using 4, right? Makes sense? Okay, so here's 3 questions for you to practice and see how you do, okay? Good luck. Okay, part A, how many ways can you arrange 3 letters from the word maple? Again, this is simply going to be 5p3. That's going to be 5 factorial divided by 5 minus 3 factorial, which is going to be 5 times 4 times 3 times 2 factorial divided by 2 factorial. You can cancel them out, and this you should get 60. Again, I think you should do it this way for now. For sure, in your homework questions, you could simply put this into a calculator, not a problem. Okay. Part B, how many letters are there how many ways are there if we arrange all 5 letters. Well, then that's simply going to be 5p5, right? Which is going to be, if you put this into calculator, 120. Or, of course, you could just do what we did last time, simplify factorial, which is also 120. Okay. Part C, how many ways are there if we just arrange one letter? Well, that's 5p1, right? We have 5 letters, we're only picking one. This is going to be 5 factorial divided by 5 minus 1 factorial, which is going to be 5 times 4 factorial over 4 factorial, which is 5. Of course, we can just pick one letter each, right? M, A, P, L, E. So 5 ways. Makes sense. Okay, now notice how this is 120. Okay, so we are gonna use the formula to solve for part B, and let's see what we notice about 0 factorial. Okay, so 5p5, if we do it by the definition, that's right. So that's gonna be 5 factorial divided by 5 minus 5 factorial, which is gonna be 5 factorial. Oops, 5 factorial divided by 0 factorial. Now notice how this and this has to be the same. And therefore, 0 factorial by definition equals 1, okay? There is one way to arrange 0 object, which is, don't arrange it, I guess. I don't know, okay? So, but anyways, 0, by definition, 0 factorial is 1, okay? Hopefully this is not too bad for you. Again, you have different objects. This is also key, hey? Notice how all these letters, I mean, if you go back to the top of the page, here it says different objects. Notice how Kelowna, all 7 letters are different, right? All 5 letters in the word maple, they're all different as well. So this works nicely for different objects. We'll deal with, like, for example, words that have the same letters, like, I don't know, apple, right? You got 2 P's. So what are we going to do about this? I'll show you this next time, okay? No worry, don't worry. It's all coming, okay? Okay, so here's the example. Use NPR formula to solve each equation for either n or r, actually just n. Okay, so NP3, NP3, by definition, this is going to be n factorial divided by n minus 3 factorial. Oh, actually, this is a typo. It should be NP2. My bad. Okay, otherwise it's not going to work. So this is NP2, n minus 2. Okay. So then this is going to be n times n minus 1 divided by, and then n minus 2 factorial divided by n minus 2 factorial. They will simply cancel out. And this equals 56. Okay, now we can expand this. We get n times n minus 1 is n squared minus n. This equal to 56. This is a quadratic equation. We can simply move 56 to the other side. And then we can factor this quite easily. Negative 8 times positive 7 is negative 56. Therefore, n either equals 8 or negative 7. Now, n equals to negative 7 does not make any sense because remember, n represents the total number of objects. You can't have negative 7 objects. Okay, that makes 0 sense. So n has to be 8. Okay. Here's the practice question for you. Give it a try, and I'll show you in a bit. Okay, good luck. Okay, similarly, again, by definition, this is going to be n minus 1 factorial divided by n minus 1 minus 2 factorial. Okay, this is going to be n minus 1 times n minus 2 times n minus 3 factorial over n minus 3 factorial. They will simply cancel out. This equals 90. Okay, and now we can expand this. You should get n squared minus 3n plus 2 equals 90. Move everything to one side to solve quadratics. So minus 88 equals 0. You can factor this. It's going to be n minus 11 and then n plus 8. In this case, n equals 11 or negative 8. Again, negative 8 does not make any sense because n is the total number of objects. Therefore, n has to be 11. Okay, so that's it. That's it for this lesson. Here are some questions for you to try. Good luck. Let me know if you have any questions.